Hello, dear students. This is lecture 9, and we are continuing our chapter 2a. In lecture 8, we discussed how we can calculate velocity from position time graph and how can we calculate acceleration and displacement from velocity time graph. In this lecture, we will study about relative velocity and then we'll continue our concept to equations of motion and various velocity time graph for uniformly accelerated motion. For understanding relative velocity in one dimension, let us consider two cars, car A and car B, moving in positive x direction. This is your positive x direction with speeds 80 meter per second and 40 meter per second respectively. Here as you can see, VB is less than VA, and now imagine yourself in car A. What you will see, if you are in car A and you will look at car B, you will observe that car B is receding away from you in negative x-axis because speed of car A is high and the distance between the car A and B will increase continuously. It is happening because car A is moving faster than car B. The second question is, what is the speed of car A with respect to B? Is it still going to be 80 meter per second or something else? Most of you can answer it intuitively that for car B, speed of car A will not be observed as 80 because 80 speed is observed with respect to some stationary observer. Speed of car is 80 meter per second with respect to ground, or we can say stationary observer, and car B itself is also in motion with respect to stationary observer. So what is this going on between two bodies which are moving together and what is their speed with respect to each other came under category of relative velocity. We represent velocity of A with respect to B by VAB in short, that is velocity of car A with respect to car B, and VBA is the velocity of car B with respect to car A, which is represented by VBA. So a shortcut for eliminating such long sentences. Next you can see there is a formula for this which you need to learn by heart. VAB is VA minus VB, and this is a vector equation, please take care. So you will do vector analysis. We are doing it for one dimension, that is why I am simply adding and subtracting, taking care of their sign. You can apply the same rules for two-dimensional or three-dimensional vectors. We will study them later in our second unit. So velocity of A with respect to B, it means if you are sitting in B, what speed you will observe A is moving. So answer is 80 minus 40, 40 meter per second. The plus sign of 40 is indicating that car A is moving in positive x direction, and that is true. You can imagine yourself sitting in car B which is moving with speed of 40 meter per second, and you will observe car A which is moving with speed 80 meter per second with respect to ground, but for you that will be moving at speed 40 meter per second in positive x direction. Similarly, velocity of B with respect to A is VB minus VA. Putting the values 40 minus 80 minus 40 meter per second. The minus sign is indicating that car B is moving towards negative x direction for A, hence having negative velocity. So as I was telling you, if you are sitting in car A and you will observe car B, you must observe car B must be moving in negative x direction as you will be overtaking that car. Please note, for stationary observer at the same time both the cars are moving in positive x direction. So at the same time for car A, car B is moving towards negative x direction, while for stationary observer car B is moving in positive x direction. So how come car B is moving in both directions simultaneously? The answer is with respect to which observer you are talking about. This thing simply explains motion is relative and is not absolute. Some position time graphs for relative velocity for motion in one dimension. Here you can see my first graph in which two particles or two cars, you can say A and B, are moving with same speed. They started at t is equal to 0 from two different positions, say P1 and P2, and as you can see there is some gap in their position. Let us say A is starting from 10 meter and B is starting from 20 meter, so that gap between them is 10 meter. A is behind B by a displacement of 10 meter. As we are working in one dimension, we can use displacement and distance interchangeably. And you are observing as we progress in time, what do we observe? We are observing as we are progressing in time, distance between A and B is not going to change. They are having same 10-meter distance between them. So this is the case if a car ahead you, say 10 meter ahead you, and moving with same speed as of yours, the distance between you will neither increase nor decrease, it will remain constant. And that is what we can observe with our graph. This distance, entire distance between A and B for all the time is going to be 10 meter and it is not changing. Second is the graph you are observing when car B is ahead of you, say at t is equal to 0 by 10 meter, and the velocity of B is greater than velocity of A. So as velocity of B is greater than velocity of A, you can see it in the inclination of B and inclination of A. Velocity of B is greater than velocity of A. Now what you are observing, as time is progressing, distance between two cars is increasing, and you can verify the same result comparing to distance here 10 meter, here distance has increased. So if a car is moving faster than your car and it is ahead of you, you are never going to catch it, and moreover distance between you will increase. Third case is car B is ahead of car A, again let us say by 10 meter, and now the speed of car A is greater than speed of car B. As you can see, inclination for B is less than inclination of A, and let me remind you, velocity is equal to tangent theta, where theta is the inclination. So tangent A is going to be greater than tangent B, or we can say velocity of A is greater than velocity of B. In this case, you must reach at a point in time where car A will overtake car B. That is the point of intersection, point of meeting, or point of overtaking. And after that, so before this meeting, distance between these two cars will decrease, will reach 0, and then will start increasing. So that will happen when you overtake some slow moving vehicle on road which initially is moving ahead of you. So VB is less than VA. So these were three cases of relative motion in one dimension. You may get different slope graphs if you will consider the directions of car in opposite direction. I'm leaving it as a homework for you. Next we are moving into chapter 2b, that is uniformly accelerated motion, and we are not going to study variable acceleration at this stage, as we will study only about constant positive or negative acceleration, and that is known as uniformly accelerated motion. So the first question is, what is uniformly accelerated motion? So uniformly accelerated motion is when acceleration is constant. Acceleration may be positive constant as I had taken in this example, or it may be negative constant. That doesn't matter. As long as your acceleration is constant, the motion is said to be uniformly accelerated motion. This is velocity time graph of uniformly accelerated motion. I had taken the value of acceleration, say 2 meter per second square. So velocity of object is increasing 2 meter per second per second. So starting from 0 at t is equal to 0, the velocity is 0 meter per second. At t is equal to 1 second, velocity is 2 meter per second. At t is equal to 2 second, velocity is 4 meter per second, and so on. On 3 it's 6, at 4 it's 8 meter per second. So you will get this straight line graph, velocity time graph for constant positive acceleration. And looking at position time graph, here you will observe a graph in this shape because as you know the velocity is increasing, and as I discussed with you, you can see inclination is continuously increasing. Here inclination is small, and then if you will consider a tangent at this point, then you will see that inclination is increased, and so on. The inclination will continue to increase as velocity will continue to increase. And you can also verify your equation s is equal to ut plus half at square at this point in this graph. So distance and time are taken accordingly. And finally the acceleration time graph, in which you can see acceleration is constant as it is uniformly accelerated motion. If it would have been increasing or decreasing acceleration, will get a slope here accordingly. So this is going to be for increasing acceleration, and this is going to be for decreasing acceleration, but we are not going to discuss increasing and decreasing acceleration at this point. Formula for uniformly accelerated motion along a straight line. So these are your equations of motion you are going to drive. We will also drive them in next lecture using graphical analysis, but first we can drive them simply by the definition of acceleration. We all know that acceleration is equal to v2 minus v1 by t2 minus t1, that is change in velocity by change in time taken. Let us consider v2 is final velocity v and v1 is initial velocity u, and t2 minus t1 is the time taken t. Putting these values in this equation, we'll get v is equal to u plus at, which is our first equation of motion and very well known. You must have studied it in class 9th. Similarly, we know the formula that average velocity, I have discussed it with you, is total displacement divided by total time, and x2 minus x1 is displacement and t2 minus t1 is time. So average is u plus v by 2, and comparing these two equations s by t with u plus v by 2 will get u plus v by 2 is equal to s by t, and s is equal to t divided by 2, and we can place in place of v, we can put the value u plus at at this point, and we'll get t by 2 u plus at, or simplifying s is equal to ut plus half at square. So that is your second equation of motion. Now from the beginning we know that acceleration is equal to a is equal to v by t or v minus u by t. So I can also say that t is equal to v minus u by a. Putting this value of t, v minus u divided by a, this value of t is equal to v minus u by a in equation s is equal to u plus v by 2 into t, which is here. S is equal to, this is the equation, so I can rewrite it like s is equal to u plus v divided by 2 into t. The same equation we are having here, s is equal to u plus v divided by 2 into t. So putting this value of t here at this place, will get s is equal to u plus v by 2 plus v minus u by a. So it's a minus b, and a plus b we can write it a square minus b square. 2a will go on that hand side, and we are having v square minus u square is equal to 2as, which is our final equation of motion. So we stop this lecture at this point. We'll see you in next lecture. Till then, take care, stay safe, study hard. See you.